Let's start talking about trig note cards 1, 2, and 3. This first note card is all about angle definitions and just kind of some things about angles to know. The first thing is you have an angle, and this should be no shock to any of you. Kind of looks like this. We have a terminal side, the vertex, and the initial side. The initial side is going to be the side that is along the x-axis, because in trigonometry what we're going to have is our angles, for the most part, are going to be on the coordinate plane. So this is the y-axis, this is the x-axis, and the initial side is going to be the side that's basically starts at the x-axis. Okay? Then you have obviously the vertex, and the terminal side is the other end of the angle. It's where it terminates. You have the measure of an angle, which is basically the amount of rotation. Here's an example of a 30-degree angle. Here's an example of a 110-degree angle. We have counterclockwise rotation measures angles in a positive measure. Okay? In other words, if we started our initial side here along the x-axis and we rotate in a counterclockwise manner, these are going to be positive degree measurements. And this is important. If we rotate in a counterclockwise degree measurement from the x-axis or the initial side, then those are going to be negative degree measures. And we're going to be talking more about that. So remember, counterclockwise, it's going to be positive, and clockwise is going to be negative. Okay, up here number 5, an angle in standard position. It's going to be the angle in the xy plane, as I was discussing, if the vertex is at the origin and its initial side is the positive x-axis. So here are 4 examples of angles in standard position. So what we have for each one, let's look at the first one. The initial side is the x-axis, and I'm rotating in a counterclockwise manner. And the terminating side is in the first quadrant. You have to remember these quadrants. Start here. This is quadrant 1, 2, 3, and 4. It's also very important in trig. Here's an example of an angle in standard position, because it starts, its initial side is the x-axis here, and its terminating side is in the second quadrant. Here's an example of an angle in standard position, because its initial side is the x-axis and its terminating side is in the third quadrant. And then you guessed it, the fourth one is an example in the standard position, because the initial side is the x-axis and it comes all the way around, and its terminating side is in the fourth quadrant. Coterminal angles are angles in standard position whose terminal sides are the same. Here are basically 3 coterminal angles, and none of them are the same measure. This first one here, again, has its initial side at the x-axis. It's rotated up here 60 degrees. This is a 60-degree angle. Something you're familiar with. You've seen those before. Not that big of a deal. This one right here, the initial side is still the x-axis, and it's negative 300, which means that it's rotating in a clockwise manner. And it comes all the way back over to here. We go from here to here. And this is new, so be patient with yourself, but this is how this basically works. If I rotate from here to here, that's 90 degrees. And then from here to here, that's 90 more. So that's a total of 180. And you should remember that 180 degrees is a line, and that's what we have here. Then 90 more is 270 degrees. And then we have 30 more degrees, and the terminal side is in quadrant 1, but I rotated 300 degrees. This is a negative 300 degree angle. But it's coterminal with this angle that's 60 degrees because it's in standard position and the terminal sides are the same. And here's another example, but this one, again, standard position, so its initial side is the x-axis. It rotates a positive 400 degrees. And its terminal side is still the same as this one and this one. Those are coterminal angles. Okay, let's talk about radians. Note card 2. These two note cards are pretty easy. On the homework assignment that you're going to get for these are just basic calculations. Radians, it says the circumference of the circle is equal to 2 pi r. 2 times pi times the radius. The unit circle, the radius is 1. Now this is important. We're going to be talking about the unit circle quite a bit. The unit circle, unit meaning 1, it means it's a circle on the xy plane whose radius measure is 1 unit. That's why it's called the unit circle, okay, because its radius is 1. Their circumference is the distance around the circle. You should remember that from probably elementary school. That basically circumference is the equivalent to this. It's the same thing to a circle as perimeter is to a square. It's the distance around it. So circumference is the distance around this circle. Radians are used to measure the length of an arc associated with the given rotation. In other words, radians are another way to express the measurement of an angle. Okay? We're used to seeing from geometry, we're used to measuring angles in degrees. Well, in trigonometry, we will use degrees sometimes, but the majority of times we use radians. And here's some equivalents. We have 2 pi radians is equal to 360 degrees. Pi radians is equal to 180 degrees. Pi halves radians is equal to 90 degrees. Pi over 4 radians is equal to 45 degrees. Pi over 6 radians is equal to 30 degrees. And pi over 3 radians is equal to 60 degrees. It says the radian is the measure of a central angle where the radius, plural, radii, and the intercepted arc are the same length is defined to be 1 radian. We'll talk about this a little bit more in depth later. Right now, what I really want you to know about radians is this. It's another way of measuring an angle. You're typically used to seeing degrees. We're going to be using radians. Okay? So moving on to note card 3 then, if you're used to seeing degrees, and degrees are used quite a bit, how would we convert degrees to radians if they're basically measuring the rotation of an angle? And here's how it works. Pretty simple. To convert degrees to radians, you have pi is equal to 180 degrees. Pi over 180 is equal to 1 degree. And so we're going to multiply each angle by pi over 180. To convert degrees to radians, we're going to multiply each angle measurement by pi over 180. Here's an example. Example 1. Very straightforward. We have a 30-degree angle. How do we convert that to radians? We multiply it by pi over 180. So 30 times pi over 180, and you're not going to really be using your calculator much here because we're not going to be using decimals here. Okay? It's like multiplying 30 over 1 times pi over 180, because when you're multiplying fractions, you have a fraction here, pi over 180. 30 is a whole number. Put that over 1. Then you multiply top times top and bottom times bottom. Well, 30 times pi is 30 pi. 1 times 180 is 180. then you can reduce 30 over 180. That's just like 3 over 18 reduces to 1 over 6. So your simplified answer is pi over 6. 30 degrees is equal to pi over 6 radians. How about to convert radians to degrees? You simply substitute 180 for pi and simplify. So if I have 5 pi over 6 radians and I want to convert that to degrees, all I have to do is substitute 180 for pi and simplify. Okay? And this is something you could probably just plug it in your calculator and get that whole number answer of 150. But basically 5 times 180 divided by 6 is 150. And so 5 pi over 6 radians converted to degrees is 150 degrees. And that's pretty much it. So we started today off with note card 1 for trig, talking about some angle definitions and some ideas about angles that maybe you haven't discussed before, such as angles in standard position, coterminal angles, and things like that. Then we talked about degrees and radians and what radians are. And now we're talking about converting degrees to radians and radians to degrees. And that's pretty much it.